Hey guys, we're going to take notes today on two different lessons together. So one's going to be titled the lesson for the first page, which is lesson 8-8, factoring the difference of squares, and then we're going to do lesson 8-9, and we're going to be factoring trinomial squares, okay? Our perfect square trinomials. Two names for the same thing. So let's, on this side, we're going to talk about lesson 8-8, factoring the difference of squares. So now this is when things start getting a little bit nitty-gritty. And it really hasn't shown up much other than looking for that GCMF first. When we forget about it, then sometimes there's a common factor lurking inside of a binomial, and we're not going to get full credit because we haven't fully pulled out all the common factors. But this now comes to the point where you need to keep checking your binomials to make sure that there isn't something more you can do. So difference of squares is hugely important, okay? So let's go back to something we talked about in the first half of the book, or first half of this chapter, I'm sorry, about what is the difference of squares. Well, in the situation where I have two binomials, where the first terms and the second terms match, but the signs are different, one's a plus and one's a minus, when I multiply them out, I get 2x minus 2x and then minus 4, and then my middle terms end up canceling each other out. The answer that I get, this guy right here, is called the difference, because of the subtraction, of squares, because both of the terms in this binomial answer is a perfect square. Okay? So what we're going to do is to go the opposite direction. We are going to be factoring the difference of squares. So I'm going to show you two different ways to do it. The great thing is, no matter what I throw at you, you can always use the product sum game and factoring by grouping strategy, okay? Every time. But it gets a little amended. Difference of squares. Okay. So first we have a pattern. I'm having trouble writing today. So we have something that looks like this. Okay? So here's what I look for. Three things. Is it a difference? So we're looking for a subtraction sign. Yep. So we say check. Is the first term a perfect square? So here's the deal when it comes to variables. I can take the square root of a variable if the exponent is even. Why? Because remember, I could rewrite this as a squared to the 1/2 power, because I have 1a squared and it's to the 1/2 power. So when I multiply 2 times 1/2, I get a. So, yep, it's a perfect square. And then is the second term a perfect square? So then we have b, square root of b squared. Same thing. We're going to get b squared to the 1/2 power, which equals b. So that's another check. Yep. So if I have all of those things work, then here's what I note is going to happen. I'm going to get two binomials when I factor. I'm going to get the square root of the first term in front. I'm going to take him and darken him up and make him a little darker. I'm going to get the square root of the second term in back. And here's what I want you to work on. One's a sum, one's a difference. Always put the difference at the end, because you're going to see what often happens when factoring the difference of squares. You still have the difference of squares as one of the binomials, and you're going to have to continue to factor it, okay? So we're always going to check the difference binomial. Okay? Now, let's play the game. So the problem in the product sum game is that we've got, let's say, x squared minus 4, and I need to have a linear term. So notice there is no linear term. So I'm going to rewrite this guy with a linear term. How do I get to do that? Well, I'm going to put a 0 in front of the variable. So if I have 0 times x, I have nothing there. So actually, I'll just do him red. Okay, so that's what goes on there. And then I have minus 4. And then what I'm going to do is play the game. So product is going to be a negative 4. Sum is going to equal 0. So what are two numbers that multiply to give me negative 4, but add to give me 0? Well, the factors of 4 are 2 and negative 2. And so those are what I'm going to put here. Okay. So I'm going to take my polynomial, and I'm going to split that middle term. So I'm going to get x squared, and then minus 4. Change my purple, didn't I? And then I'm going to get minus 2x plus 2x. And then I'll just factor by grouping. So these are going to give me an x, and that's going to give me an x minus 2. And then these guys are going to give me a positive 2. An x minus 2. And then I factor out the common factor of x minus 2. And the two other terms form their own binomial. Okay? So I get the same kind of answer. It just takes me a little bit longer. So you can do it this way if you want to. Okay? So again, what you're looking for, is it a difference? That's first and foremost. If it's not a difference, if it's a sum, then it's not the difference of squares. Is the first term a perfect square? Is the second term a perfect square? So when you go back and you see what you have here, you're going to have signs are different. One sum, one difference. So I'm going to write that word above. Sum and difference. And you're going to have the square root of the first term. So I'm going to write that here. And b is the square root of the second term. Okay, so if you recognize it is a difference, the first term's a perfect square, the second term's a perfect square, so I'm going to take the square root of the first term, put it in front of both binomials. I'm going to take the square root of the second term, put it in the back of both binomials, one sum, one difference. Okay, so let's see if we can, we'll see if we can manage to get all of these on here. Maybe, maybe not. So directions are going to ask us to factor. And the first problem, we have 16n squared minus 9a squared. So first thing I look for is a GCMF. So I'm going to just put this off to the side. GCMF, question mark. And 16 and 9, nothing in common. The two variables don't have anything in common, so the answer is no. So then we're going to check for the difference of squares. So it's a difference. Can I take the square root of 16 n squared? And yes, 16 is a perfect square. I get a 4. N squared is a perfect square. I get an n. Can I take the square root of 9a squared? So I'm not worrying about any signs right now, right? So square root of 9 is 3, and square root of a squared is a. Okay. So then I'm going to go ahead and form my two binomials, since it meets all three criteria. Yes, yes. So square root of the first term is 4n. So 4n is going to go in the front of both. And then square root of the second term is 3a. That's going to go in the back of both binomials. And then we're going to get one sum, one difference. The only place I need to look is at this guy, the second one, and see if I can continue taking square root of both parts. Now, 4n, 4 is a perfect square, but n isn't. So as soon as I see something that I can't take the square root of, I finish up. So there's my answer. 4n plus 3a and 4n minus 3a. All right, let's do a second one. b to the fourth minus 16. Okay, so is it a difference? Yep, meets that criteria. Can I take the square root of b to the fourth? Yeah, half of 4 is 2, so I get b squared, so that works. Can I take the square root of 16? That equals 4, so yeah, that works. So go ahead and create my binomials. I'm going to have b squareds in front. I'm going to have 4 in the back. I'm going to have a sum. I'm going to, a sum, and then I'm going to have a difference. Huh. So I look here, and I recognize, oh, look at that. I've got a difference. I can take the square root of b squared is b. I can take the square root of 4 is 2. So this is what I'm talking about, how important these difference of squares are. So I still have b squared plus 4. He's not going to change, but now b squared minus 4 is going to get replaced with two new binomials. So I'll use green for the first term, and I'm going to use pink for the second term, and then one sum, one difference. And the only place I need to look is here. B's not a perfect square, so I'm done. See what I'm talking about? You got to keep going. This is going to be the challenge, is to keep going. Now, let me give you one more, and then we'll go to the trinomial squares. So we need to go through our process. It's a difference, so then I can consider other factors. All right, can I take the square root of t to the 8th? Well, yeah, half of 8 is 4, so I get t to the 4th. And then can I take the square root of 1? Yeah, absolutely, square root of 1 is 1. Okay, so we have yes, yes, yes. So, two binomials. Actually, you know what? I'm going to put it off to the side. Oops. And we're going to do the binomials over here so you can see the big chain. So we're going to have t squared, or t to the fourths in the front. We're going to have 1s in the back. We're going to have one sum and one difference. So the only place I'm going to be looking is here. T to the fourth, ooh, even exponent. Yeah, I can take the square root of that. So I'm going to use a different color now. So square root of t to the fourth equals t squared. That's perfect square. We have a difference. We have a perfect square. And then can I take the square root of 1? Yep. it gives me 1, so he's a perfect square. So that guy is also the difference of squares. So we have the first guy is going to stay the same, and then t to the fourth minus 1 is going to split into 2 new binomials. So we have t to the fourth plus 1. And so for this next round, we're going to get t squared in the front of the binomials. We're going to get 1 in the back of each binomial. We're going to have 1 sum and 1 difference. So again, the only place I need to look is here. Holy smokes. It happened again. So we end up with t squared. When I take the square root, I get t. When I take the square root of 1, I get 1. So all 3 criteria are met. It's a difference. I can take a square root. I can take the square root. So here we go. We still have the first guy. We still have the second guy. But now the third guy is getting split into 2 new ones. So we still have t to the fourth plus 1. We still have t squared plus 1. We're going to have t in the front of each of the last 2 binomials. We're going to have 1 in the back of each of those binomials. We're going to have 1 that's a sum and 1 that's a difference. The only one we have to look at is here. T is not a perfect square. I'm finally done. Okay? Whew! All right. Onward and upward. We're going to talk about lesson 8-9. And that's going to be factoring a trinomial square, or a perfect square trinomial. Factoring a trinomial square. I think I say trinomial square because it's fewer words compared to perfect square trinomial. Okay, so again, we need to remember what happened in the first half of the, I'm going to put underneath here his name, or I'm going to put it here, perfect square trinomial. It's kind of a misleading because not every term is a perfect square, just the outer edges. So let's go back to what we did in the beginning of the chapter. So if I had a binomial that was going to square it, we could expand it and multiply, and we would get, n squared plus 2n plus 2n plus 4, and that would simplify down into n squared plus 4n plus 4. So this answer is what's called a trinomial square or a perfect square trinomial, okay? And so we have 2 possibilities. I'm going to go back to kind of the algebraic versions where we have a sum that's being squared. And we talked about how, if I notice that my first term ends up being squared in my answer, and my last term ends up being squared in my answer, but how do I get the middle term from the original binomial? If I multiply it and double it. So that's the pattern we discovered. So I take the first term and square it. Whatever this sign is goes here. So I'm going to add, and then I'm going to double the product of the 2 terms. And then I'm going to take the last term and square it. So that gives me a squared plus 4ab plus b squared. And the only other case is, what if I have a negative binomial and I want to square it? Same thing. The only thing that changes is the sign here. Gets written here as a minus, right? And then to get the middle terms, I'm going to double the product of the 2 terms. I don't worry about the sign. I've already accounted for it over here with the plus. And then it's always going to be positive because a negative times a negative is a positive. So they give me a squared minus 2a. Sorry. I went too far on this one. Sorry. This one is just a and b. I'm going to double that, and that's how I get 2ab. Sorry for the mess. I was just stuck on the other problem. So this would give me negative 2ab plus b squared. Okay. So now what we need to do is we're going to try to factor a trinomial square, but in order to factor it, we need to see if it is a trinomial square. So how to factor a trinomial square. First thing we need to do is recognize if it is a trinomial square. Okay, so what am I looking for? Let's bring one up. Let's go. We've got 4y squared plus 12y plus 9. So here's the first thing you have to look for. First, is the last term positive? That's the first thing. If that's a negative, then don't even. Go back. Okay? Then we're going to look for second thing. Is this a perfect square? The first term, is he a perfect square? Then we're going to look at the end. Last term, a perfect square? But you're still not done. After those three yes, 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 you need to check the middle term, and he's the hardest one. Is the middle term double the product of the square roots? It's a lot of work you have to do. Of the first and third terms. Okay? If you answer yes to all four of those, then you have it. Now, of course, I'm going to show you how to do it in a fast way. Why? Because I like to do things fast. Actually, let's go over to this side over here where I have more room. So our directions are going to say factor. So I'm going to count this as 1 because this is the first example on this side. So this is this fast way that I like doing it. Okay, so is my third term the last term positive? And the answer is yes, it is. Okay, and then is the first term a perfect square? Well, let's try it. Well, the square root of 9 is 3. Square root of y squared is y. So, yep. Is the last term a perfect square? Can I take the square root of him? Yep, I get 4, so that works. Then I work on the middle term. If I double the product of those square roots, do I get the middle term? And the answer is yes, I do. So here's the deal. In that process of me checking things out, I already have the answer. I need this square root, I need this square root, and I need the sign of the middle term. Those three together, 3y plus 4 quantity squared. And that's my answer. Okay, let's do another one. Let's say we've got, I don't know why I like 9. 9x squared minus 48x plus 64. All right, so first thing, is the third term positive? Yep. If the answer is no, I stop right there. Then can I take the square root of the first term? If I say no, I stop right there, and I'll have to go back to factoring, playing the game. So square root of 9 is 3, square root of x squared is x. Is the third term a perfect square? Yes. Square root of 64 is 8. Now comes the test. If I double the product, and I'm not going to worry about signs, of the two square roots, do I get the middle term? So I get 6 times 8 is 48. I get 48x. So I had yes, 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 yes. So I grab just the 3, the square root, and the sign of the middle. So I get 3x minus 8 quantity squared. And there you go. All right, good luck with this, guys. See you later. Bye.